Okay, new chapter, Algebra 1. We've got chapter 5 beginning. Chapter 5, section 1 is solving systems by graphing. We did quite a bit of graphing in chapter 4, so we're going to continue that just a little bit. There's going to be three methods to solve systems. There's going to be graphing, there's going to be substitution, and there's going to be elimination. And by the time we get done with these three, you're probably going to pick one that you like the best, and you are welcome to use it on the exams and the quizzes once you learn all three. You do not have to use the specific one that it's asking for. Pick the one you like, and then we will move on. So here we go, systems. We, in the last chapter, maybe graphed something like this, and then maybe we graphed something like this. So we had, in that first one, we have a slope of 2 and a y-intercept of -8. And the second one, we have a slope of -4, and we have a y-intercept of 2. And so because now there's two of them, it's called a system. Okay, systems work together, they work off of each other. And so solving these, if I graph those two lines, and they're obviously not parallel because they don't have the same slope, they would intersect somewhere, and that's the solution. That solution is going to be in coordinate form. It's going to have an x value, and it's going to have a y value, and it's simply where those two lines would come together. What that means is that if I put in that x and y value, it would solve both equations. So let's take a look at one without even graphing it. They're going to give you some, and they're going to give you the equations. So let's say x plus 7, no, let's do this. Y equals -2x minus 4. That's my first part of my system. And my second one is going to be y equals x plus 4. I'm just going to split them up. And they're going to give me a coordinate of -2, 0. Their question is this the solution to this system? Well, I don't have to graph this. All I have to do is substitute. Remember that in this case, for this coordinate, x is -2 and y is 0. So I'm going to substitute those values into both of those equations, and let's see what happens. So over here, everywhere I see a y, I'm going to replace it with 0. Everywhere I see an x, I'm going to replace it with -2. -2 times -2 is +4. And 4 minus 4 is 0. So far, this one works. Okay. So now we go over here, and I replace y with a 0 as well. I replace x with -2. And I get 0 equals -2 plus 4, which is +2. Okay, this one does not work. So -2, 0 is not the solution. If it were the solution, then this value over here would be true instead of false. Okay, over here, 0 equals 0, that's true. But on the other side, it was not. So let's take a look at one that might work so you can see. We have x plus y equals 7. Our second equation is going to be 2x minus 3y equals -11. And they're asking us if the coordinate 2, 5 is going to work. So x is 2, y is 5. Let's sub them in. Obviously over here, that one's going to be pretty easy. 2 plus 5 equals 7. That is correct. So we're good so far. Over here, we're going to have 2 times x, which is 2 times 2, minus 3 times y, which is negative 3 times 5. 2 times 2 gives me 4. Negative 3 times 5 gives me negative 15. And 4 minus 15 gives me negative 11. So in this case, okay, both of these do work. And so yes, 2-5 or 2,5, the coordinate 2,5 is a solution. Okay, so let's take a look at some actual graphs. And let's graph to find solutions where they won't give them to us, we actually have to find them. So let me take the equation y equals negative 2x plus 5. And I'm going to go ahead and do the slope and y-intercept. The slope in this one is negative 2 over 1. The y-intercept is 5. And then my second equation is going to be y equals 4x minus 1. Where in this case we have a slope of 4 over 1. And we have a y-intercept of negative 1. So let's graph these real quick. The first one, my y-intercept is 5. And my slope is negative 2 over 1. So I'm going to rise negative 2, which means I fall. And then I run a positive 1. So I'm going down 2 and to the right 1. I could also go up 2 and to the left 1. It works. So here is my line there. I would advise you at this point, just to make sure you can graph okay, is to go ahead and hit pause, graph the second one, and then come back up and come back up online and see if it works out. Okay, so we're back. If you paused, or if you didn't pause and just left it going, then it is what it is. So our second one, our y-intercept is negative 1. It's right about there. And then my slope is up 4 to the right 1. And we just found our intersection point because it intersected perfectly with our graph. So our solution is 1, 3. Now, we can check real quick to make sure that works. So let's go up to the top one. My y value, x value is 1. Y value is 3 of my coordinate. So is 3 equal to negative 2 times 1 plus 5? Is 3 equal to negative 2 plus 5? Okay, yes, that one works. So let's check out the second one. Is 3 equal to 4 times 1 minus 1? So is 3 equal to 4 minus 1? And yes, that one works. So my solution is the coordinate where they intersected, which is 1, 3. This is the moment why I've been asking you all of these times to draw with a straight edge, make your graphs perfect, because we need those perfect intersection points. We don't need them intersecting in half a box and having to guess what it might be. So that's a little under 10 minutes. That is Chapter 5, Section 1, Solving Systems by Graphing.